Welcome back to AI on AI, the show where we don't just talk about cutting-edge systems. We unpack their mechanisms, economics, and the edge cases that matter when you deploy at scale. Today, we're diving into multi-agent penetration testing for the web, a system that moves from pattern spotting to adversarial execution with proof-of-concept validation. And we'll anchor on results from a 104 challenge benchmark and real apps where high-impact vulnerabilities were found in minutes, not days.
The heart of this shift is bridging the semantic gap. Static patterns say, "This looks like SQLi," but the runtime says, "Prepared statements negate it." Multi-agent systems fix that by reasoning about code and then acting through tools until they get end-to-end evidence, which is a sea change from possible vuln to verified exploit, with a reproducible artifact and an oracle that says pass or fail.
Concretely, the architecture runs three roles in concert. One coordinator agent plans and delegates, sandbox agents execute in an isolated per-job container, and a validation agent takes candidate exploits and actually runs them. The per-job Docker gives you state continuity, cookies, enumerations, word lists, without cross-job contamination, and the validation agent forces a binary outcome, exploited or not.
From the business lens, that binary is gold. It compresses triage time and cuts noise, which means security leaders move from weeks of false positive wrangling to hours of real fixes. And strategically, the cost curve bends because successful runs tend to consume fewer tokens, tools, and minutes, so you can set budget guardrails and still raise coverage across the portfolio.
The orchestration logic is evidence-gated. The coordinator synthesizes hypotheses up front, sets gating predicates like endpoint exists, auth obtained, then delegates bursts of enumeration or payload crafting. Every tool output feeds back into those predicates, and when preconditions are met, the system assembles a minimal POC and hands it to validation for a hard verdict. No report goes out without that check.
That discipline, verify by execution, also mitigates ethical risk. The system never strays into destructive operations. Everything runs in an ephemeral container, egress is controlled, and only minimal evidence and logs persist. On the governance side, that aligns neatly with responsible disclosure, auditability, and SOC workflows because you're storing short-lived artifacts and signed POC scripts rather than raw data dumps.
Let's talk performance. On that 104 challenge benchmark with modern web stacks, the system solved over 3/4 of the tasks, aced SSRF and misconfigurations, delivered strong results across SSTI and SQLi, did well on command injection, but struggled with blind SQLi and only did moderately on XSS. What's the root cause of those gaps? XSS is deceptively hard for agents that don't fully emulate a browser DOM. Reflected payloads are easy to validate, but DOM-based syncs, CSP interactions, and sandboxed iframes require headless browsing, event simulation, and CSP inference. Blind SQLi is about oracles, time-based and out-of-band, so without an adaptive statistical test that separates network jitter from true latency signals, you get false negatives even when the payload is correct.
Exactly. Putting numbers to it, the blind SQLi zeroed out because we lacked a robust hypothesis test. Add a sequential probability ratio test on timing, run multiple randomized baselines, and gate on confidence intervals, and you can turn intermittent delays into a signal. For XSS, arm the sandbox with a headless browser and instrument syncs, inner HTML, eval, URL handlers, then label exploit success via DOM mutation or alert equivalent callbacks.
It's also a planning problem. XSS often wants multi-step state, login, navigation, template injection, then cross-origin pivot. We've found finite state modeling with explicit session reasoning helps. Treat cookies, tokens, and CSRF as first-class state variables, maintain an execution history, and have the coordinator ask, what state do I need to reach before this payload matters?
And strategically, those gaps argue for staggered investments. Phase 1 goes after high-yield categories, authorization bypass, SSTI, SQLi, SSRF, where we see 75 to 100% success. Phase 2 funds deeper browsers and timing oracles. Phase 3 is business logic choreography, because that's where revenue leakage hides, and where agentic testing shines against traditional scanners.
You all mentioned resource guardrails. The analysis showed strong negative correlation between success and resource consumption. Fewer tool calls, fewer tokens, shorter time correlate with wins. What thresholds should leaders use? A practical rule of thumb: if you haven't made meaningful progress by roughly 40 tool calls or 5 minutes, your probability of success drops. So you implement early stopping, cut the long tail, and redeploy those cycles on new targets or a different strategy. It's like triage in an emergency room. You don't keep running the same test indefinitely when the vitals tell you it's not working.
I'm going to be a bit contrarian. Early stopping maximizes efficiency but can miss slow burn vulnerabilities like blind SQLE or multi-hop auth chains. What you really want is adaptive stopping. Track uncertainty in the plan using entropy over candidate attack paths, and only stop when both the plan's confidence is low and the marginal information gain of another tool call is minimal.
Right. This is where Bandit algorithms help. Treat each toolpath pair as an arm, reward as validation success, and use upper confidence bounds to explore undersampled paths. Couple that with validation feedback, and you've got a closed loop that reduces waste without prematurely abandoning complex but solvable cases.
There's a governance twist too. Route slow burn categories to a scheduled window with relaxed caps, and keep your default CI/CD gates strict. This keeps build pipelines fast while allowing deeper assessments to run as nightly jobs where time is cheaper and fatigue doesn't hit developers during the day.
Let's ground it with real outcomes. You tested 10 popular open source applications locally and found nearly 20 issues, most high or critical. Give us the flavor of those findings without naming names.
One was a command injection, hiding in a database export utility. User-influenced parameters flowed into a shell command that wrapped a database dump. We validated by escaping the parameter into a harmless shell echo to prove arbitrary command execution. Another was client-side secret exposure. Server-side API tokens were baked into a JavaScript config endpoint. The posse simply retrieved the page, parsed a known variable, and used the key to call a protected API.
We also saw a post-message-based RCE. An overly permissive origin check allowed an injected script to call evaluate on untrusted text. We crafted an HTML harness that posts a function string from a controlled origin, then validated execution by writing a unique marker to the DOM. No damage, just evidence. And there was an unauthenticated email relay with SSRF potential, accepting arbitrary SMTP creds and remote file URLs. So we used a non-sensitive internal metadata URL as the oracle and looked for specific response substrings.
The arbitrary file write case is important for defense in depth. Client-controlled toolchains allowed file operations to be merged with privileged actions. The agent packaged a non-invasive payload that attempted to write a benign marker file under a constrained path and then read it back. Those cases underline why end-to-end validation is critical. They shift the conversation from maybe dangerous pattern to here's the effect we achieved, here's how to fix it.
Business impact-wise, we've seen teams fold this into 3 workflows. First, CI/CD gates for critical services, where a passing suite requires 0 validated PUCs against a curated set of checks. Second, weekly sweeps across long-tail services, where the early stopping heuristics cap runtime and concentrate attention on likely wins. Third, quarterly deep dives, including browser-enabled agents, to hunt XSS and blind classes. One consumer fintech saw coverage rise by about 1/3, and triage workload drop by over half after they switched to POC-only findings.
Let's dive deeper into the multi-agent design. Why not a monolith model that just does it all?
Specialization reduces cognitive clutter. Coordinator thinks strategically and remembers the plan. Sandbox agents focus on tactical execution in a narrow context, and the validator acts like a judge. Think of a pit crew. One calls strategy, one changes tires, one refuels. Mixing them slows everyone down and increases mistakes because the token context gets noisy and the agent oscillates between planning and acting.
The shared per-job container is the unsung hero. Agents retain state across steps, authenticated sessions, reconnaissance outputs, compiled helpers.
Yet their LLM contexts remain separated, so you don't keep repeating or resummarizing massive logs. Amateurs talk strategy, professionals talk logistics. Logistics here is the tool substrate, state reuse, and tear-down discipline.
I'll add a technical flourish. The system normalizes tool outputs into observations tied to predicates. When a predicate flips, say admin endpoint exists, that triggers a new branch in the plan. The validator becomes the oracle for success, which is how we measure and improve. In God we trust. All others must bring data.
Isolation matters. Each job runs under a hardened profile. Restricted network egress, read-only mounts where possible, ephemeral secrets injected at runtime. At the end, we purge containers and only keep minimal evidence. You can add seccomp, a parmor, and outbound allow lists to prevent tools from reaching sensitive networks during testing, which is critical for enterprise risk posture.
Business case number 2. Outside of CI, how do platform teams get leverage from this during incident response or major releases?
2 patterns: release certification and purple team rehearsal. For release certification, you run the agent suite against staging just before cutover. If no validated POCs emerge across critical categories, you ship. We've seen teams cut pre-release security cycle time by roughly a third, while increasing defect catch rate. For purple team rehearsal, you schedule controlled offensive runs and feed their exact POCs to detection engineers. False positives drop because detections are calibrated against verified behavior, not hypotheticals.
And the evidence artifacts are small and surgical. HTTP sequences, minimal payloads, or short Python scripts. That's crucial for SOC handoff. They can replay and confirm within minutes. Compare that to traditional scanner logs, pages of pattern warnings without a reliable way to reproduce. The benchmarks category breakdown was revealing. Perfect on SSRF and misconfig, high on SSTI and SQLE, strong on command injection, moderate on XSS, and 0 on blind SQLE. What would you implement first to close that last gap?
A timing oracle library with noise models. We'd instrument baseline latency for each endpoint, randomize payload order, and apply a sequential hypothesis test to declare an effect. Combine with Boolean-based payloads where possible to reduce reliance on timing. For environments that allow it, out-of-band DNS HTTP callbacks provide a high-signal oracle, though you'd keep those sandboxed and properly logged to avoid abuse.
We'd also add a browser-aware agent for XSS, headless runtime, CSP introspection, sync instrumentation, and a library of contextual payloads that mutate based on framework fingerprints. Pair that with a DOM diff oracle and you convert may be reflected to executed under these constraints.
Don't forget access control. Broken authorization was a standout success because the agent systematically tests privilege boundaries. Scale that by importing role models from your IAM, then auto-generate role-labeled sessions. It's a path to catching BOLA-style issues in APIs where the surface area is too large for humans to cover consistently.
There's a striking statistic in the analysis. Success correlates negatively with time, tokens, and tool calls. Efficiency equals wins. But is it the whole story? Mostly, quick wins usually mean the plan matched the target's weak spot. When the agent wanders, it's often because the target needs a specific oracle or a rare payload. That's where dynamic search shines. Switch tools, test a different class, or escalate to the browser agent. But the baseline heuristic, cap at around 40 tool calls or 5 minutes if there's no signal, will save most teams a lot of compute without giving up much coverage.
The non-obvious bit is that oracles are the bottleneck, not model intelligence. If your validator can't reliably tell you, this worked, the agent either stops short or goes on a goose chase. We should invest as much in oracle design as we do in model upgrades. Synthetic canaries, side effect probes, and transaction markers turn ambiguity into results.
Agree, and we can learn oracles too. Train a classifier over validation traces to predict likely exploit before running the costly POC. If confidence is high, prioritize validation. If low, deprioritize or explore other branches. This is how you compress cost without missing opportunities.
From a portfolio view, the second-order effect is capacity arbitrage. You redeploy cycles from targets that look cold early to risky targets that are heating up. Third order, democratizing autonomous testing pressures marketplaces. Vendors with strong POC discipline win, while pattern-only tools get squeezed. It also changes staffing. You scale senior oversight across more services while moving junior effort to remediation and hardening.
Let's talk ethics in emerging markets. Continuous autonomous testing is a dual-use capability. How do you deploy responsibly across regions with different constraints?
Start with containment by default. Local-only runs for white box assessments, strict outbound allow lists, and red team windows approved by governance. Add evidence retention caps, days, not months, and scrub secrets from logs. In stricter jurisdictions, prefer on-prem inference, local repositories, and no out-of-band callbacks. All of this is configurable so you align with data sovereignty and regulatory expectations.
In bandwidth-constrained environments, the early stop and cached context tricks matter even more. You want short, punchy sessions, fast enumeration, tight POCs, minimal retries. Practically, that makes autonomous testing viable on modest infrastructure without sacrificing safety.
And we should be honest, attackers will have this too. The best defense is to match their speed with verifiable insight, then shorten the remediation loop. Test like a thief, verify like an auditor is a useful mantra here.
On the white box side, how do you reconcile source-aware detection with runtime proof?
Think hybrid. Static hints prioritize dynamic probes. If the code shows a tainted sync, the coordinator elevates that path in the plan, and the sandbox executes the minimal run to validate. Source gives you coverage, execution gives you truth. In practice, that synergy is how we found the file write and the origin check flaws quickly.
Business case number 3. A healthcare platform integrated that hybrid into their developer platform. Changes that touch sensitive modules trigger focused runs. Over 2 quarters, they saw defect discovery shift earlier in the cycle, and critical findings validated within hours instead of weeks, which, beyond risk reduction, boosted developer trust in security because the feedback was specific and actionable.
It also smoothed compliance audits. Auditors like reproducible evidence. You can show them the exact POC, the validator's result, and the remediation PR. Far better than arguing over scanner severities.
Roadmap time. If you had to prioritize the next 3 technical milestones, what would they be? Browser-empowered agent for DOM XSS and client flows. Hardened timing oracles for blind injection, and a playbook for multi-step business logic exploits. Cart manipulation, approval bypass, and race conditions with precise oracles.
I'd add a reinforcement layer that treats validation outcomes as rewards. The coordinator learns which tool plans work per framework fingerprint, Django, Express, Next, and front-loads them. Plus, a canary placement system for white box runs. Instrument the app to make exploits more readily detectable and reduce false negatives.
Finally, a knowledge substrate mapping CWE families to tool strategies and oracles. It's like a pressure map. Given a stack, here's where to push and how to know you succeeded. That boosts sample efficiency from the first minute.
Practically, how do leaders adopt without boiling the ocean?
A 30 to 60-90. First 30 days. Pilot on non-critical services, tune caps, align evidence retention, and set KPIs like coverage uplift and mean time to validate. Next 60. Expand to critical services with CI/CD gates for the high-yield categories, and schedule weekly sweeps. By day 90, plug browser and blind Oracle modules into a monthly deep dive, and push validated findings into ticketing with owner mapping and SLA clocks.
And wired into processes you already have. Change boards, secure SDLC checkpoints, bug bounty triage, give developers a replay button and a remediation snippet, set up a defensive-only mode for regulated environments with strict egress and kill switches. The smoother the handoffs, the faster you see risk drop.
Before we close, one more speed round. Single best heuristic each of you would give to a team rolling this out tomorrow. Cap at around 40 tool calls and 5 minutes, unless the validator is warming up. Watch for early sign signals to decide whether to continue or switch tracks.
Treat oracles as first-class citizens. If you can't measure it, you can't fix it. Invest in timing tests, DOM diffs, and side effect markers.
Separate thinking from acting from judging. Keep contexts lean for each agent. Specialization outperforms monoliths.
Default deny your environment. Restrict egress, scrub secrets, minimize evidence retention. Safety first earns you the right to scale.
Only ship POF-backed findings and measure downstream impact, coverage, resolution time, and reopen rate, because outcomes are the strategy.
That's a wrap. Today we saw how multi-agent, tool-grounded, proof-validated testing moves security from hypothesis to evidence. It delivers high success on categories that matter, exposes where oracles need work, and gives leaders the levers, caps, gates, and governance to scale defensibly. As always, the quote that fits: all models are wrong, but some are useful. The useful ones bring data, act with restraint, and leave you safer by the end of the run. Thanks for listening, and we'll see you next time on AI on AI. Before we let you go, let's land the plane. Quick end-to-end recap, the breakthroughs, and how leaders can operationalize this tomorrow without breaking stride.
Big picture first. This shifts security from pattern suspicion to provable impact. The business upside is cleaner triage, fewer reopens, faster mean time to validate, and coverage uplift. Because every finding is a verifiable POC, you spend time fixing what matters and stop arguing about scanner severities.
Technically, the core innovations are the three-role split: coordinator for strategy, sandbox for safe, stateful execution, and validator as Oracle, plus a single per-job container that shares runtime state while keeping LLM contexts lean. Add evidence-gated predicates, early stop heuristics after roughly dozens of tool calls or a few minutes without signal, and you get a system that learns when to push and when to pivot.
And we've got a crisp gaps to roadmap story. Bolster blind injection with timing oracles and sequential tests, bring in a browser-capable agent for DOM-driven XSS, and layer a reinforcement loop that maps framework fingerprints to the most effective playbooks. The result is higher first-pass hit rates with fewer retries.
Governance matters. Default deny your egress, ephemeral containers, short evidence retention, and clearly separate fast CI gates from deep nightly hunts. That's how you scale autonomy responsibly across geographies and regulations while keeping auditors and engineers on your side.
One last slightly contrarian nudge. Invest as much in your oracles as in your models. Synthetic canaries, DOM diffs, side effect markers. When validation is strong, even a modest agent looks brilliant. And when it's weak, the smartest model just burns cycles.
Final highlights then. Multi-agent specialization cuts noise and boosts throughput. Tool-grounded execution and end-to-end validation turn hypotheses into evidence. Resource-to-success correlations give you pragmatic guardrails, and a hybrid white-box runtime flow accelerates discovery where it counts. Prioritize high-yield categories now, expand to browser and timing oracles next, and run a 30-60-90 rollout to embed this in CI, weekly sweeps, and quarterly deep dives. Net effect, more verified coverage, less triage drag, safer deployments. Thanks for staying with us. This was AI on AI, where useful beats flashy and evidence beats opinion. We'll be back with more systems that move the needle in the real world. Until then, test like an adversary, verify like an auditor, and ship like a pro.